Still working.
I got it. I got 9x over y to the second square root of y.
Yeah. I got that.
So remember, our first step is to just take the square root and put it on the top and on the bottom. That's the first step. Then from there, you've got to break up each square root individually. So on the top, I want to look at the number first. Can I take the square root of 9?
Oh, yeah, 3.
Yeah, it's 3. So on the top, I've got 3. Can I take the square root of x?
No.
No, there's not anything bigger than it. It's just x to the first.
So it just stay with?
So it's just x. Yeah, I can't pull anything out of that square root. So the top part's done.
Y2? Yeah.
So on the bottom, I'm going to have
Y to the second.
y to the second and the square root of y.
Wait, you don't put those together?
Because if I divide this y to the fifth, the 5 by 2, it goes in there twice with a remainder of 1, and the remainder is how many y's go on the inside.
Divided.
If I multiply anything by 1, does it change it? 1 times x is still x. 1 times anything is still whatever it was when I multiplied it by 1. So if I multiply this fraction by something on the top and on the bottom, it's not going to change the fraction because technically that's 1. So I need to multiply something on the top and bottom to get rid of the square root on the bottom. What is it going to be? It'll be the square root of y. Let's talk about why that is. Okay. Right now I have 1 y underneath the square root, right? And how many do you need before you can pull it out of a square root?
1, 2.
You need 2. So I've only got 1 y, so I need another y underneath to be able to get rid of the square root on the bottom. But if I add a square root of y on the bottom, I have to add a square root of y on the top to keep the fraction balanced. Just like you do in an equation. Like what you do to the left side of the equation, you have to do the right, and vice versa. What I do to the bottom of a fraction, I have to also do the top. Because really, if I took this fraction, the square root of y over the square root of y, the square root of y over the square root of y, that's just 1, right? Because if I have the same thing on top and bottom of a fraction, they would cancel out and equal 1. So really, I'm multiplying this fraction by 1. So it's not changing the value of the fraction, but it's going to make it look a different way to get the square root off the bottom. Let's look at how we're going to simplify the top. I have 3. And since I'm multiplying 2 square roots together, I'm going to multiply what's underneath the square roots together and put it all under 1 square root. So it's going to be 3 square root of xy.
The square root cancels out.
I already have a y squared on the bottom, so when I multiply square root of y times square root of y, it's just going to leave me with 1y underneath. Because y times y would give me 1 pair of y's, so I'm going to pull 1y outside. Or y times y is y squared, and 2 divided by 2 is 1, so there'd be 1y there. However you want to look at that, it doesn't matter.
So the y's don't combine?
Well, they do. That's just what we're about to do next. So, what we need to do, on the top I really can't do anything. It's still 3 times the square root of xy. Then y squared times y is going to be what? Y to the third. So that's going to be my answer. So, first step would be to separate the cube root on the top and on the bottom. Then, the same as we did with the square root, we want to simplify the top and the bottom. So can I take the cube root of 8? What's the cube root of 8? It's what? It's 2. Because 2 to the third is 8. If I break down 8, I could break down 8 if I wanted to. Because I can break down 8 into 3 2's and have a set of 3 2's, so I can pull that out one time. So you can do that the same way we did it when we simplified fractions. Now with the power of x, the exponent of x is 5. So I divide 5 by 3, and 3 goes into 5
2x.
one time. So it'll be x to the first, or you don't have to put the exponent there. Then what's going to be left under the cube root?
2.
X to the second.
X to the second. How can I break 64 down? Or does 64 have a cube root? Well, I could do 8 times 8. And then I could break each of those down into 3 2s. So I've got one set of 3 and one set of 3, right?
2 times 2 is 4.
It'd be 2 times 2 on the bottom, because I have 2 sets of 2, which is 4.
Whoa, how'd you raise that on the other?
I undid. Okay, hit undo.
Man, yours.
So since the power of y is 4, what I need to do, I need to divide 4 by 3. 4 divided by 3, 3 will go into 4 one time, which we don't need the exponent of 1, I was just writing it. Then we have a remainder of 1 left on the inside. So I'm going to have to multiply something on the top and the bottom. I just got to decide what that is. How many y's do I need to be able to pull out one y out of the cube root on the bottom?
3.
You need 3. How many do I have?
1.
1. So when I multiply, I need to multiply by what? Y to the second. On the top and the bottom. From here, what I have on the top, I've got 2x. When I multiply cube roots, it's the same thing as the square roots. I'm going to have x squared and y squared on the inside. Then on the bottom, I've got the 4y. Then if I were to just multiply the cube roots together, I would have y times y squared. From there, I can't simplify anything else on the top, because I've only got I've got x squared and y squared on the top, but I need 3 to be able to pull something out, so I can't do anything else with the top. Then on the bottom, I've got the 4 and the y. And then on this bottom over here, if I multiply y times y squared, I'm going to get what? Y to the third. And y to the cube root of y to the third is going to be what? Y. So I'm just going to have a y on the bottom. So I'm just rewriting the top. So on the bottom I have 4 times 4y times y, which is y squared. So my answer is that. Alright. Free response question, I would count this right because the AP test would count this right. But the 2 and the 4 on the top, we have to see if anything on the top and bottom will cancel out. I'm going to write it below here. So I have a 2 on the top of this fraction, and I have a 4 on the bottom here. Alright, so I can cancel out the 2. Alright, because on the top, 2 will go into 2 one time, 2 will go into 4 2 times. I don't have any more x's on the bottom. I don't have any y's on the bottom and the top, because since this y is inside this radical, I can't cancel those two things out. So your answer, you should also be aware that your answer could be x, because 1 times x is just x. So I could write the 1 in front, but I don't have to. I need to write another x. Cube root of x squared y squared over 2y squared. So you need to be able to simplify this. So we're going to split the fourth roots up on the top and the bottom. Then from there we need to see what we can simplify. Right, I can't break 7 down at all, so I can't simplify the 4th root of 7, so I just got to leave it as the 4th root of 7. Can I break anything down out of 3x on the bottom? No, I can't break anything down, but I've got to get rid of the square root on the bottom, correct? So I need to do something to the top and the bottom. Erasing all that? Okay, well, I'll put it back. Well, I can't do anything to simplify the bottom. So really it didn't do me any good to write that down. Alright, so I can't simplify anything on the top or the bottom. So what I need to do is multiply by something on the top and the bottom. So what can I... So, we know that I'm going to have to multiply by a 4th root on the top and a 4th root on the bottom. I've got to multiply by a 4th root on the top and the bottom. But I want my 4th root to make what I multiply by, I want it to make the bottom root radical disappear. So I need to figure out what do I need to multiply by to make this 4th root disappear. I have 1 3. How many 3's do I need to be able to pull one of them out? I need 4, so what am I going to multiply by here? You can make it an exponent, so it can be 3 to the what? 3rd. I've already got 1, so 3 to the 3rd is going to give me the 4 that I need to pull 1 3 out. Right, and I've got 1x, so my x needs to be to the 3rd as well. So, and then whatever I do to the bottom, I got to do the same thing to the top. Like that. Because now, if I put these two things together, I've got 4 3's, so I can pull 1 3 out. I've got 4 x's, I can pull 1 x out. So I have 3x on the bottom. And it's always going to work out that way if you multiply the top and bottom by what you're supposed to. Then on the top, I'd have the 4th root of 7 times 3 to the 3rd x to the 3rd. Which on a multiple choice test, they're probably going to want you to multiply that out. That doesn't really look like a 7. 7, 3 to the 3rd, x to the 3rd. So they're probably going to want, so that'd be 27 times 7. Alright, which is 189, I think. So we'd have the 4th root of 189 x to the 3rd over 3x.
Did you not pull stuff out of 189?
I thought you were asking if I...
First step is to split it up like it is. Second step is to see if I can simplify the top or the bottom. I can't do either here. So my next step is to multiply something on the top and the bottom to get rid of the radical on the bottom. Well, to get rid of a 4th root, I'm going to have to multiply by a 4th root on the bottom.
Gosh, I had the wrong sign.
Alright. In order for a 4th root to go away, in order for me to pull something out of a 4th root, I need how many?
4.
I need 4 of something. How many 3's do I have?
1.
So I need how many 3's do I need on the what I'm multiplying by?
3.
3. So I can write 3 to the 3rd, or you can write 27, however you feel comfortable doing that. Right. Then what else can I have 1x, so I need 3 x's.
And you do the same thing on top.
Right. So whatever I do on the bottom, I must also do on the top. So what that will give me Alright, is on the top, I'm going to have a fourth root of, and then y'all should be able to see it, 7 times 3 to the third, x to the third. Because when I multiply two radicals together, if they're the same, then I can just put it all underneath 1. Make them a big happy family. Now on the bottom, the reason I chose this to multiply by is so it would make the fourth root go away, and what am I going to be left with on the bottom?
3x.
3x.
Yay.
So after you multiply all that out, you're good. Yeah, you need the
I'll
fourth.
trade you 60 football schedules for my mama.
Because I'm zoomed in really far.
So we can fit more stuff
Have a square root on the bottom. And normally what we would do is we would just, like, your first reaction may be to multiply by the square root of 3 on the bottom. If you had a natural reaction
Thanks, Bob.
to this problem. Alright, but if I do that and I distribute the square root of 3 and distribute the square root of 3,
Then you end up with
I still going to have square root of 3 on the bottom because square root of 3 times 1 is square root of 3, so that doesn't help me at all. So I can't do that.
I would think that multiply by the square root. By the square root.
So since I can't just multiply by one thing and get rid of the square root, I have to multiply by the top and the bottom by the conjugate. And it's the conjugate of the bottom. I want to multiply it by the conjugate of the bottom. So what's the conjugate of the bottom?
1 plus radical 3. Right?
Yes.
Yay.
1 plus root 3. So I got to multiply by that on the bottom and on the top.
The cancels out the bottom, right?
Not quite. So let's look at it on the bottom. All right, remember, because we're trying to become more familiar with difference of squares. This is why it makes your conjugate life a lot easier.
My math life's not easy.
They're exactly the same on the top of the bottoms, right? Except for this is plus and this is minus.
Yeah.
So instead of falling out on the bottom, we can just multiply 1 times 1, which gives me
1.
1, and then square root of 3 times the square root of 3 is what? It's 3. And then what's going to be in the middle?
Subtraction.
It's a minus sign. Now on the top, they have the same sign, right?
Yeah.
So I can't do that. I have to full out that.
The heck? Okay.
Here's another trick, though. That's why I chose this problem. I want you to see. If I full something out, full two things out, and they're exactly the same. Alright, you'll see how they're exactly the same. Alright, so it's plus and plus. Alright, so how this is going to be is I can multiply 1 times 1. That gives me whatever's in front, the two front things. That gives me 1, right?
Yep.
Alright, then I can multiply the two back things. Square root of 3 times square root of 3 gives me
3.
3. And since these signs are exactly the same, this is plus and this is plus, even if it was minus and minus, a negative times a negative is a positive, positive times positive is positive. So this sign's always going to be plus here. Then whatever the sign is, since they're both plus, that means this is going to be plus. If they were both minus, that means this is going to be minus. Then what I do is multiply the two things together. 1 times the square root of 3 is what? Square root of 3, and then I just I multiply about that by 2, so it'd be 2 root 3. That's a formula that we're going to learn later on in the year. Then we have to combine what we can combine. So on the top I've got 1 plus 3, which is 4, plus 2. Then over 1 minus 3. Can I take 3 away from 1? No, so it's negative 2. I cannot combine anything on the top of this fraction.
You can divide by the 2.
Like, can you not sample? Can you not?
If I can split anything, like I can split different things up in math. If I had the distributive property of something and I had something on the outside, I would give it to both of them, right? Y'all understand that?
Yeah.
Alright. Well, I've kind of got a distributive property going on down here at the bottom. So really what I could split this fraction up, alright, into 4 over negative 2 and 2 root 3 over negative 2. I could split that fraction up into this and that if I wanted to. So we want to simplify. 4 divided by negative 2 is negative 2. And then here I can't really divide that, but I've got a this is all this multiplication on top. Alright, so I could 2 divided by negative 2 is negative 1 or negative root 3. So negative 1 times root 3, or I don't really have to put the 1 there. So it's just negative root 3.
That's the answer.
And then this is my answer.
Okay.
Alright, so we need to... So on the bottom, like when I work fraction problems out, any fraction I'm doing where I've got to do some extra math, so I'm going to be fulling on the top. I'm going to be doing difference of squares fulling on the bottom. I just make a big fraction. I'd work out the bottom, put it on the bottom, then I work out the top, put it on the top, so I keep everything organized. That's how I do it. Alright, so now on the bottom, I just got to multiply the two front numbers together. So that's square root of 3 times square root of 3, which is what? 3. Which is square root of 9 is 3. Then the square root of 5 times square root of 5 is?
5.
5. And what's going to go in the middle?
Negative.
Minus. Good. Alright. So now on the top I need to FOIL. And if it helps you, you can put parentheses around these so you can see that it's full. Some people don't understand that it's full unless there's parentheses there. Alright? But even though there wasn't parentheses, alright, I'm multiplying a 2 term and a 2 term, so I have to full out. Alright? Alright, so our first step is to multiply the two front ones. So that's 3 root 2 times the square root of 3. Now what I want you to become familiar with this and do this a little bit quicker. So we're going to I'm going to show you the best way to do it. First thing you need to check, are the square roots the same?
No.
Square roots are not the same. Alright, so they're not going to disappear. Alright, so multiply the front numbers together. 3 times 1, so that's 3. Alright, then the square root of 2 times the square root of 3, without having to multiply, it's just going to be the square root of 6. Because it's not going to simplify anyway. Alright. Then my next step of full is multiply the two outsides. So it's the square root of 3 root 2 times negative root 5. Are the square roots the same?
No.
No, it's going to be 3 minus 3 root 10. Now, on the inside, here I've got 2 root 5 times root 3, which is going to give me what?
2 root 15.
2 root 15. Then the last step, this is the main thing I want you to be faster at. Alright, my last one is 2 root 5 times root 5. Now the roots are the same, right? Alright, it's going to be, alright, you're still going to multiply the front numbers together. Like if this wasn't a 1, I'd multiply by whatever that was. So 2 times 1 is 2. Well, the square root of 5 times square root of 5 is just 5. So 2 times 5 is 10. So I can't simplify the top at all because there's no like terms. But I can do something on the bottom because I can do 3 minus 5. And 3 minus 5 is what?
Negative 2.
Yes, negative 2.
So that's about negative 2.
Well, after I write down the really long numerator again. All over negative 2. So you can leave it like that. So